Okay, so let's start. So, yeah, last time fine, we had seen about generics. Okay, so yes, there was one question which was related to unbounded wildcard with lower bound, right? Where does it fit in the type hierarchy, super type subtype relationship? Okay, so that was one question which was unanswered, so I'll do that. But any other questions which you have got?
Sir, are there any raw types in generic?
Okay, now see, generics was introduced at a later stage, right? It was not right from the beginning, first initial version of Java, and whatever, it was more applicable to the collection framework. The collection framework has been there for a long time. Okay, so to have compatibility with the old code, whatever backward compatibility for the existing code. Okay, so existing code would not have used a type parameter. Okay, for example, we have the list interface right from the beginning. We have the collection interface from the from Java 1.2 onwards. Okay, so if anywhere collection has been used and no type parameter has been specified, yeah, that is still acceptable. Okay, so when we have a generic, so if I take that example of collection, right? So we have the generic interface called collection. Okay. We have the generic interface called collection, right? Okay. One second. Okay. So we have a generic interface collection. Now, prior to Java 5, it would have been used as collection only. Fine. It didn't have, so when someone was using collection, it didn't specify it's a collection of string or account or anything. Okay. This is post Java 1.5. Fine. From 1.5, okay, you would have said, oh, it's a collection of string, or you would have said it's a collection of. So you specify. Whenever we use collection, we specify something. Maybe with the wildcard, bounded wildcard, unbounded wildcard. But whenever we say collection, we have to say it like this. But all other previous usages, right, prior to Java 1.5, it would have been written as collection only. Okay. So when we just write collection for some generic type, so collection is a generic interface, and if I just write collection, this is what we call as the raw type. Okay. Fine. So raw type means this one. Okay, so this has been allowed because of giving the backward compatibility, but it's not a good idea to use it now that way. Okay, because then you are not using the type check system which is available. Okay, the type checking has been available because of this, right? It is doing the type checking basically, that you are using it correctly or not. If you have said it's a collection of string, it allows you to add only string in that, right? Fine. Okay. Yeah. So fine. So that is basic thing about the raw type. Okay. Now coming to that last time's thing. Okay. Last time question. It was related to the type hierarchy, right? Super type subtype relationships between the various type of invocations of a generic type here. So if I say list of, yeah, so we had taken that example as list of question mark, which is the unbounded wildcard. Okay, this was also we said, okay, this is almost same as saying list of, these are both same, question mark extends object. Okay, and then we had gone further and said, okay, we'll have a, so one of the types under this would be list of object. Okay, fine. And another subtype would be list of question mark extends. If it's a list of question mark extends object, any subclass of subtype of object, so we will say, oh, list of question mark extends account. We have taken example as account. Okay, fine. And then a subtype would be a list of account. One of the subtype was the list of account. Okay, you can see that this and this, they don't have a supertype subtype relation here. Okay, now coming to the use of super. Now a super will not be related to extends in a supertype subtype relation. So if there is something which says extends unbounded wildcard with upper bound, no, you can't have it assignable in any way to a unbounded wildcard with lower bound. No form of assignment is allowed here. Okay, so this cannot be related to that. But then with respect to list of account, okay, a super type of this. So irrespective, so this has one super type which says, oh, it is also, it's a super type of list of question mark extends account, but it's a subtype of that, but it is also a subtype under list of question mark super account. Because if it's a list of question mark super account, it would mean it includes list of account and list of any super type of account. Okay, fine. So super would be independent of the extents. They don't relate to each other. Super and extents, they would not be ever related in super type subtype directly. Okay, but yes, as far as a specific type is concerned, yes, with respect to this, they are both super types. Extends is also a super type and super account is also a super type. Now another thing, just if I consider this, right, okay, another super type to this would be, it's, see, now understand, it's going to be a super type. So I am just writing it here, list of question mark super current account. Is a super type for list of question mark super account. It's a super type. Okay, because when it says list of question mark super current account, it would definitely include anything which is account and a super type of account. Okay, and then the list of account is under this. And list of account. So here I have said list of account. One super type is this, but on top of this, any subtype of this, a super for any subtype of this would also be included. So they become super types, further super types. Okay, so that is how things would work. Okay, see, this super type subtype relation is being shown purely from the point of view of what is assignable to what. Okay, if I have a variable which is declared of type question mark super current account, okay, I can assign to it a variable which is declared of type question mark super account, and to that I can also assign a list, a variable which is a simple list of account. Assignability point of view. Okay, so if you consider here, okay, so if I just consider like this, this is L1, okay, this is L2 and this is L3. Fine, it should be possible for someone to say L1 is equal to L2 equals L3. Okay, list of account is assignable to list of question mark super account, which is assignable to list of question mark super current account. Okay, but the other way around would not be allowed, okay, in any of those two relationships, L1, L2, L2, L3. And you can't reverse any of those two relations. Okay. Fine, is that clear? I mean, last time this was one of the questions, right? Okay, just a few other things which I think I didn't mention last time related to generics. Okay, it was like this. So if you are defining a class, recollect now again this, I had mentioned about list class. Okay, we started with saying class account of, let's say, B, or fine, whatever the type parameter may have been. So let's consider just one type parameter maybe. Fine. Okay, implements and whatever other things may have been there. Now one thing here, when I said B, right, where is B going to be used? We say, oh, B is used like a data type, right? It's used in place of a data type throughout the definition of account class. Within the account class, B is a data type which will be decided by the one who uses the class B. Okay. But one thing, okay, here, if someone says, let me have a static variable, okay, of type B, then it is not allowed. Fine. Or someone says, let me create, okay, so someone says, okay, I have got a variable of type B, instance variable BAL, or anything, any variable name may have been there, equals, and let me create an object of this. So calling constructor not allowed. Okay, fine. So you can't have because you don't know what type it is, you don't even have any what are the valid constructors which should be available. So this is also not allowed. Another thing which would also not be allowed, you may have declared a variable, this is also okay. Okay, fine. Maybe you want an array of the type parameter, you can declare variable, but fine, declaring variables is okay. But someone says new B, I want 5 array with 5 elements of type B. No, this is also not allowed. Okay, allocating object or allocating an array for the whatever is the type parameter is not available. Usage in static context is not available. Fine. So keep those things in mind. Fine. Otherwise, yes, this is used just like a data type within the class account. Fine. You understand why not with static? Because look at B, how is it going to be used? I had mentioned about the balance thing. What was it? Not balance, about the generic thing. So, see, how are we using that? How are we using? When I say account of long, okay,
with the instance.
yeah. So it is associated with the instance AC1. For AC1 it is long. For AC2 it will be something else. So these are all related to instances. They require objects. They are not, the type parameters are linked to the object. They are not without the object. Okay. The type parameters are used for specific objects. In this object, this is the type parameter. For a different object, it is a different type parameter. When we talk of static, it is nothing to do with the object. So wherever we have a static context, the type parameters are not available. Okay, fine. Of course, a static method the method can have its own type parameter. So even a static method can have a type parameter. Okay, but when there is a static type parameter for a class or even an interface, in a static method, right, you won't be able to use that type parameter, or with a static variable. No, you can't. Fine. So that makes sense for the generics. Okay. So still any questions related to generics? Then we'll proceed. Yeah. Anyone has questions? Yeah.
Hello.
Yeah.
Yes, I was saying we can use generics with array
With
or not.
generics with
Array.
array. Yeah, yeah.
Yeah.
We had the example generic array, right? Or okay, okay. Now, yeah, one more point. It's good recollected this. Another thing about the type parameter is a type parameter is always a reference type. A type parameter is always a reference type. So when, for example, when we initially started and we said, okay, we will have a there was no bounded type parameter, it was a simple type parameter, and we just said account of an, recollect this, and I said account number. Now if someone was saying that within this when he invokes an, I have not put any bounds here. Okay. Now invocation like this is also valid. If someone says account of string array, fine. So it's a type. So what you can't do, okay, this is one thing, this is one way of invocation, but if someone invokes like this account of int, that's not valid. Not for primitive types, it's only for reference type. Okay. When you invoke, the type parameter will always be a reference type. Okay. So arrays are reference types. Okay. This is not allowed, whereas int array, that is fine. Okay. It's a reference type, not primitives. Except for primitives, for invocation, yes, you can use anything. Okay. Now, yeah, go ahead and say your question was related to, can we use with array, generics and array? Yeah.
Yes, sir.
So was it about this one, this case, or yeah?
Yes, yeah, yes.
Okay. Fine. Okay, so any other questions? Yes. Yeah. Okay, so then we proceed to the next topic, right? Okay, so now let's talk about Java 8 features. Okay. Generics has been there from Java 5, so that's a feature of Java 5. Okay, but is very much most of the things here are going to be dependent on generics. Fine, so it was very useful to have the topic on generics. Okay, so let's have the next things. So first thing, let's see the changes in interface. Yeah, that was one of the questions last time also. What are the changes in interface which have taken place? Okay, so interface earlier, prior to Java 8. Okay, so in an interface prior to Java 8, yeah, we had modifiers, we had interface keyword followed by name of the interface. Okay, followed by type parameters if it is a generic one. Fine, we understand that now. And then it could have extents and a list of super interfaces. okay, comma separated list of super interfaces. The important thing about the very distinguishing thing about the interfaces was that interfaces have methods, but they have no implementations. That was the case earlier. They were all abstract methods only, right? Here, if there is a variable, it was always a static constant. So, you could have, I will just put it static constants. You do not have anything like a static block here, okay? You do not have instance block or a static block in an interface, not allowed here. Okay. You could have static constants, that is public static final variables. Fine. When I say static constants, it would mean static constants are nothing but variables which are declared to be public, static and final. Okay. Your variable, and they would need an initialization there itself. When you declare, you initialize it with some value. It is a constant, non-changing. So, it is a static constant, so that is fine. And other than this, the only other thing which was allowed earlier, so this is prior to Java 8, was you could only have public and abstract methods. So, the way the language was designed was you do not declare public abstract, okay. Just write a method and declare a method, and I understand because it is inside an interface, this is public and abstract. So, methods were always public and abstract, fine. Now, what Java 8 has done is, okay, because they wanted to give backward compatibility as well as upgrade the API. Okay, you would like to upgrade your API to include more methods, enhancing the API, fine, enhancing an interface. You want to enhance an interface to include more methods, more meaningful methods. How do you add them? Without breaking backward compatibility. So, that is where they said, okay, let us put another term as default. So, they added a default method. So, you could have a default method. Okay. So, default method means a modifier for default available for methods, but this default modifier for method is available only for interfaces. In a class, you can't give a default modifier for a method, okay, only for methods in a interface. These are like instance methods. Okay. Mainly the idea here is that this default method would be inherited by a class which does not have an implementation of this method. Okay. So, the idea was that yes, because I am enhancing, I want to add a method, I can add as a default method, and then any old API, if it would, since it would not be implementing this interface, fine, it would not have implemented a particular method. Okay. So, this method implemented, a default implementation for the method is available here. So, these are actually meant to be overridden in a class, but this availability is there only for old classes which never implemented it earlier. Okay. So, with this idea, methods, default methods with their implementation is available. So, if it is a default method, it would contain a method body, there would be statements in this. Fine. They were always public, these default methods were also public. So, all members in an interface were always public. Okay. Fine. So, Java 8, yes, they said, oh, we will have default method also, and since we are having default method, what is the harm in adding a static method? Because static method even could have been added earlier also without any harm, because it has nothing to do with the objects, does not participate in inheritance kind of a thing. So, you could even have static methods in an interface, static method, okay, with their body implementation. So, static method Yeah, static method means yes, you will have the prefix of the interface name. So, so in a interface like so many new interfaces have been added. So, any interface may also contain, okay, for example, we have the interface called comparator, and in that comparator interface they have added so many static methods which can create comparators for us, to easily create comparators. So, method like a factory. So, static methods to return objects of that type. So, static method in interface to return object of that interface type. Of course, we do not directly have object of the interface type. So, it would be having some class which is implementing that interface. Okay. Fine. So, two additions which came in Java 8 were default and static methods were added. Okay. Fine. Now, a static method or even a default method, when we are writing such methods, maybe there are a number of methods which we are writing, and many times it may so happen that we have some repetitive code. Some part of the code is being repeated again and again, again and again. What do we do when we have repeated code? Put it in a method. Fine, put it in a separate method, but that method is for internal consumption. That means it should be a private method. Okay, that's where they said, okay, you could have a private method. So, Java 9, this is Java 9, this, okay, the private methods in interface introduced from Java 9. Okay. So, you could have private methods, just say private. Okay. So, otherwise all members in interface were public, but we now have public and private, no others. Okay. Even if you say default, it would mean public, default would mean public. If you want private, you have to use the word private. Okay. And private, and you straight away put a method, then this is like a private default method. Okay. A default method being private. So, you do not use the keyword default, just say private, it would mean default and private. And if you want static method to be private, fine, you can have the word private as well as static both, and have your method. When I have just said method, when I am writing method here, it means a return type, whatever else is needed, the parameter list and method name, everything. Okay. And it has its implementation body.
So, this implementation will be inside interface only?
It is within the interface to be invoked from some other static method or from other default methods. They might like to call a private method, because a number of places, maybe I am repeating something, right, a very repetitive code. So, if I have some repetitions, okay, we normally can do such things, right, put a private method and invoke from that. Fine, when we are writing inside a class, we do that way. Okay. Fine, if there is a class where you have a lot of methods and some of the methods have repetitive code. So, that repetition part, maybe factor it out, create a private method, because it is not part of someone else's to be using it, right. It is for internal consumption, internal use within this class only, right. We use private methods for that purpose, because it is internal use within the class. So, same purpose, internal use within the interface. So, private methods introduced in Java 9, okay, introduced inside the interface. So, these are the changes which have come to interfaces.
So, the class to implement this interface,
Yeah.
So suppose let's say this interface has defined this method, private statement.
Yeah.
Into implementation.
Yes, yes.
So, those would be available as a factory implementation in the class to implement this interface, right?
Factory means a static method we use as a factory many places, right. Static methods are used as factory, right.
Yeah.
Okay, what was factory method? Let me again explain. Okay, I will put the example from the API here. Okay, let me put a new page. Okay. So, just an example of factory. So, from the API, I was mentioning about the public interface. So, we have this Java util package where there is a public interface called comparator of type T. Okay. Now, in this comparator of type T, okay, there is a method. Okay, fine. This had that abstract method. Recollect the abstract method here, which was returning int. Name of the method was compare, where parameter were t, right? That's your object 1 and another t for the object 2. So, comparison of 2, that is what was to be given. So, this was the abstract method which we had. Okay. So, that same abstract method remains here. Okay. So, this is anyway there, they can't remove it because it's been there from earlier time, fine. And this is what is the crux of comparator basically. The idea of comparator is it's used for comparing two objects. Okay. But what they have done here is they have even added static methods. But what does the static method return? The static method returns, okay, because it's a static method, it would have its own type parameter. Now, this t would not be available there. So, when I am writing, maybe I will write as u, okay. So, static method with a type parameter u, and it returns a comparator of u. Okay. Name of the method is comparing int, and parameter is a the parameter to this would be a to int function func. This is C. To int function of okay, here because we are talking about u, it's a to int function of u. That's a parameter to the comparing int method. Fine. So, this is your function. Fine. We will be covering what is this to int function and all those things. We will be coming to that also. But fine, just to show an example. So, the static method is used for creating object of comparator type. It is having methods to give me objects of comparator type. This kind of method we call them as the factory method. Okay. And so, it is a factory static method in a type to return the object for that type.
Yeah. So, implementation will be in class, right? It won't be defined here as a body type.
Okay. Now, this is a static method and would have its own implementation, which is there in the comparator.java. Yeah, it's there. The code is there for in comparator.java. How they do it?
Yeah.
Okay. Even you will be able to write this method, but yes, first you should then what you should be doing is you should first be knowing about what is this to int function. Fine, you'll have fine. We'll have to look into all of those aspects.
Yeah.
Okay.
Sir, can you can explain the factory methods?
Okay. Factory is nothing but your static method basically. It's your static method. Okay, fine. How do you create object of a wrapper class? If I say integer class, I'll just take another example here. Integer class. If you look at the class integer, fine. Within the class integer, we have a static method. What does it return? Integer. Name of the method? Value of. Right? Takes a int, the value as a parameter. So, that is a factory method, I will put it that way. Right? It is a factory basically based on a factory pattern. Fine, let's so the idea is, in a type you have static method, because static methods are not linked to objects. Static methods are independent things. Okay. See, here static methods cannot be using instance variables directly. They don't have this. So understand that as far as any static method is concerned, okay, the static methods could have been in another type also. Same thing could have been in a separate place. Instead of having this method called value of in the integer class, someone could have written a separate class called integer utility, and then put that same static method here. What is the difference? The difference is, to use that method I am using integer dot value of now, but instead of that I would have been using integer dot, it's the name, the prefix name which is only changing. I would have been saying integer utility dot value of. So static things, look at them as some fixed thing, you can put it anywhere, fine. Wherever you are putting, that prefix is coming. Static is global kind of a thing. Okay, fine. See, you write interfaces. Interfaces allow static methods. Okay, and therefore, if you could easily write a interface called hello interface with a public static void main, and let it print hello world there. Fine. So hello world is not necessarily, the main method is not the static main method is not necessarily only in a class. It's available for use in an interface. It's available even in an enum. So you could use either of those three things now. From Java 8 onwards, yes, you could use even an interface to include a static method, a main method, and then you could use Java and give the name of the interface to invoke the main method. Fine. So you can easily have your own hello interface. Is this fine? Static methods. And okay, so fine. What we were looking at was this. Static method returns the object of the same type in which it is existing. Right. So I want object of this type. Okay, there is some static method in that. I'll just straight away use it. So maybe interface, maybe class, whatever. Fine. It's objects are not created only with constructors. Fine. We have static methods. And sometimes people refer to it as static factory methods. Okay. Fine. Okay, so two new things, default and static methods, that's the main thing. Okay. Now the important part. Okay, one of the important concepts which we started discussing last time was about a function type. They use this interface also to represent a function type. So some of the interfaces were used for representing the function type. Okay, fine. So examples of okay. So what is a functional? So they have what we call as a. So they categorized. So when I talk of interfaces, we have interfaces which are marked as functional interface. So let's look at the definition of what is meant by a functional interface. So any interface which has only one abstract method, okay, any interface which has only one abstract method is a functional interface. Okay, interface is marked as having only one abstract method is a functional interface, and we already had many such interfaces in Java which had only one abstract method. Okay. See, it says having only one abstract method. It doesn't say you can have other things. In that interface, you may have default methods, you may as many as you like, you may have static methods as many as you like, but abstract method should be only one. Okay. So many times people refer to it as SAM, single abstract method. Function interface means single abstract method. Okay, fine. But there is slight, there's one small difference here. Not exactly single abstract method. Okay. For example, our comparator interface, which I had written earlier, has got two abstract methods. It's more than one. Let's okay. We refer to it as E. Let's say now. Fine. I am just referring to it as comparator of E, some element type E. Okay. So the interface comparator of E has got two abstract methods. Which are those two abstract methods? One method I had mentioned earlier, int compare, parameter is E, that is your object 1, another is object 2. Okay. So this is one of the abstract methods, and the other abstract method is again a public method returns boolean, name of the method is equals, parameter is object. Okay. But then still comparator is still going to be called as a functional interface. Why? The reason is, when we are saying single abstract method, we do not count public methods of the object class. If there is any public methods of the object class, this is not to be counted. Okay, we do not count this one. So, from if we ignore any public methods of the object class, then the number of abstract methods is only 1. Fine. So, comparator has two abstract methods. Equals method has been declared as abstract in the comparator. Okay. But it does not make it a non-function interface, because we do not count methods from the object class. Public methods. Okay. Fine. What I am mentioning is the public methods of the object class. Remember, there are two protected methods of the object class. So, keep in mind. So, those methods, no, if they are declared abstract, then they have to be counted. And which are those two protected methods of object class? Protected methods from the object class. Yeah, there are two of them. Protected void finalize and protected returns object, name of the method is clone. Okay. So, these are protected, other methods of object are public. Fine. So, if there are public methods which have been again declared in an interface to be abstract, do not count them while counting single abstract method for a function interface. Okay. Fine. So, now because of this, many existing interfaces qualify as function interfaces. Fine. Many of the existing interfaces have become functional interfaces, they qualify as function interface. So, examples of function interface from the API, whatever you know, one of them I have already mentioned is comparator. Yeah, what else? Any other function interfaces? Okay, let us take this example of comparator the way it was in Java 7 prior to Java 8 without those static methods. Okay. It had just those two abstract methods, that was it. right? And I have to ignore the public method of the object class. So, I will say mainly if someone had to write a comparator, what was the common way of writing comparator? Maybe we had generics from Java 5. So, I will say it is a comparator of account. If someone had to write a comparator of account, okay, fine, maybe comparison based on balance equals, yeah, how was it being written prior to Java 8? Let us see this. How would you write it? You would be doing nothing but new comparator using the anonymous nested class, anonymous inner class, where we will say, okay, now override the public method returns int name of the method is compare with parameters as account AC1 comma account AC2. Okay. Write your implementation to return a value for the compare method. Fine. This is how it was written. So, what was comparator? What was comparator? The important thing in comparator was the implementation of the abstract method of the interface. In order to create an object of comparator, we have to have an implementation of compare method, some place where we have an implementation of compare method. Fine, there will be different implementations in different objects. Okay, or basically, can I say balance comparator is nothing but this kind of a function? What is a balance comparator? Balance comparator is an object. If I look at it as a function object, it would take as input an account, right? Any account object will be taken as input and it would be returning an int value to me. Right? Or compare, okay, basically compare method. So, two account objects, sorry, it takes two account objects, yeah, it takes two account objects and returns a int for me, right? That is what a comparator is. A balance comparator is nothing, if I say comparator of account, that means some object or some function which takes two account objects and returns a int value. Okay, fine. And last time we were looking at how do we write such a function. So, instead of writing like this, new comparator and in this way anonymous inner class, right, I could have written it as, okay, yeah. So, balance comparator, see. So, someone could have even written it as balance comparator equals, fine, the implementation of, fine, this, if I have to write this function, how do I write it? As a function, I will say, okay, account is even, I may not even mention, right, the types, or if you want, let us declare the type. This is also fine, account AC1 comma account AC2, fine, and then the lambda operator, fine, and then we have the lambda operator. this is known as dash greater than, this is known as a lambda operator, and then we can write a implementation which is returning in the way it has been done here inside this. So, I am not mentioning the name of the method here, but I am writing the function. Okay. This is a lambda expression. Lambda expression is nothing but that function. So, what is a lambda expression? If you look at what is a lambda expression, someone says, oh, what is a lambda expression? The lambda expression is an implementation of the single abstract method of a functional interface. We cannot have a lambda expression which is not in context of a functional interface. If you are not having a functional interface, there is no lambda expression at all. Because comparator is a functional interface, and therefore, I can have a lambda expression for objects of type of the type comparator. Comparator is a functional interface, or we will say it is a function type. Comparator here is a function type. What type of function? Oh, the type of function which takes two inputs. How do I decide it takes two account as input or two t as input? Okay, two elements as input and returns a int. See, what was important for me to write an object of a comparator was to know that it has two inputs, and the implementation here should know that I have to return a value of type int. From the body of the implementation, I must return a int. Okay. So, what is the lambda expression now? It is a function. Which function? A function which is an implementation for the single abstract method of a functional interface. So, if I have any functional interface, yeah, now you can give me some example of any functional interface. I have given one example of functional interface which has only one abstract method. Yeah, there are so many existing functional interfaces even prior to Java 8. So, examples of those. Yeah.
Sir, action listener like that.
Action listener, okay. So, if someone is writing GUI and he wants to use action listener, yeah. Action listener has a single abstract method called action performed. Parameter is a action event, but return type is void. Okay. So, action listener AL equals, yeah, what is the parameter? I know it is an action event type. I need not even mention the type AE. I am just saying a parameter name is AE. Sorry, it looks separate. They are not. There is no space here between A and E. Okay, and I will just put it that way. Okay, AE. Okay, and then a lambda operator, and then it depends. Now, here if what I am doing is only a single statement, okay, return type is void. So, there is not going to be a return statement. I might just say system.out.println. If it is a single statement, I do not need braces. Fine. System out println and println, yeah, whatever, maybe AE dot something, fine, and that is it. Okay. So, this semicolon, single statement like this. If it is multiple statements, start braces, and you have all the statements and braces, semicolon. A block. Okay. Fine. Fine. Is this clear? Okay. let me just put a lambda expression, and can you and I'll ask you to give me what is the type. So no parameters and a set of statements. Can anyone guess what's a type? A function interface like this. You use multi-threading, right? Find a function not taking any parameters returns void, return type void. When this is nothing but this lambda expression represents some function, okay, which does not require a parameter, but has a set of statements to execute, but it will never be returning a value, return type void. So what? There you go. Fine. So fine, you think this is a runnable interface, right? Just writing a lambda expression, fine, by just having a lambda expression, you can't say what type it is. Okay, suppose I write a lambda expression, yes, we get that impression that you have the runnable interface, right, which has this method, one abstract method, return type is void, name of the method was run, that is what it is. Yeah, this fits that, right. So it seems to be of type runnable, fine. But if someone is putting like this, someone says, let me have object obj equals, and puts a lambda expression like this. What do you think happens? What should happen? Can the compiler decide what is this lambda expression representing? Which type does it represent? Understand, Java is a strictly typed language. Type for everything has to be known at compile time, which means that this kind of a code is a compilation error. This is a compilation error. Okay, what you want to assign object, you can assign anything to an object, right? You can assign anything to an object. Why not this function? But this function, what is the type? Tell me what type does it represent? Because there are other places, there can be any other interface which has a similar signature. Not only runnable, some other interface also may have a method which is a return type void, which has no parameters. Oh, it represents all such things. So tell me what it is. So if you want this assignment to be successful, what you will need is, you will need to do cast to a runnable. If you cast to runnable before the lambda expression, then you have set the type for it, and then yes, okay, now this is a runnable, I am taking it. So if there is a lambda expression which is being used, the type of a lambda expression is always determined from the context where it is used. Okay. Earlier, when I write action listener AL equals, because on the left hand side I have mentioned action listener AL, because of that it knows that this thing is a type action listener. The entire thing, entire lambda expression is of type action listener. It is known because of the left hand side. Okay. Or even if another usage, let me just show, because this is always determined from the context. The type of a lambda expression is determined from the context. Okay. So, for example, you might just imagine someone says, I have a method and I will be returning action listener object to you. Action listener, Li, this is I. Action listener, I return action listener, there is a method M1, okay, maybe it does not take parameters, and what it does, it has a lot of other coding, but towards the end, it is writing this code which says AE, okay, AE and then lambda operator and a set of statements, semicolon. Okay. This is what is the code towards the end of, at the end, oh sorry, here it says return, yeah. Return AE and all this. See one thing, in a lambda expression, if you only one parameter, okay, you may not even use the brackets. Fine. I didn't use the bracket, otherwise normally you put them in bracket, parameter list is in bracket. Okay. Fine. So, even if you do not put bracket, that is also fine, but that is fine only in case of a single parameter for the lambda expression. So, if there is a single input parameter for your lambda expression, you may not have put them in bracket. So, if I have said return and like this is valid. It understands that here, what is the return type for this method M1? It says action listener. Oh, this signature for the lambda expression which I have written, it matches that action listener's abstract method signature, and therefore this is valid. This is understood as an action listener because the method is going to be returning an action listener. So, from the context it can determine, that is fine. Okay. Otherwise, you should do a casting. Okay. Lambda expression just independently, if someone writes a lambda expression, no, you can't make out what type it is. Fine. So, assigning direct, almost anything can just be assigned to a object, right? Object being a super type for all of them, but a lambda expression can't be done that way. Fine. Any questions?
Okay, sir.
Okay. Fine. Fine. Everyone should be comfortable. What is a lambda expression? What is a function? Okay, two things what you have to be clear about is what is a functional interface. Fine. So, everyone clear what is a functional interface? Interface with a single abstract method. Okay. Sometimes you might have an interface which is inheriting a single abstract method, that is okay. Fine. It should effectively have one abstract method, effectively. Fine. And when counting that single abstract method, ignore any public method of the object class, do not count them. Okay. Fine. So, if there is a function interface F1, someone extends from that and creates a function interface F2, does not add any new abstract methods, F2 is also a function interface. Fine. Or F2 overrides that abstract methods by giving a default. Okay. F2 is overriding the by giving a default and adds its own abstract method. Then also fine. Effectively one abstract method for that type. Okay. So, those functional interfaces, all functional interfaces, look at them as function types. Okay. And what kind of function? The function type is nothing but whatever is the method signature of that single abstract method which we are determining. So, we have counted one abstract method. Oh, what is its method signature? So, that decides what kind of lambda expression you can have for it, what kind of functions it represents. Fine. So, function interface and lambda expression, what is the structure? Okay. So, let me give the lambda expression examples. Lambda expression, so some function, so it will have a list of parameters. So, in the list of parameters, I am just giving as an example, right, int a comma int b. This I am writing for a function interface called int binary operator. Okay, fine. A lambda expression, lambda operator, hyphen greater than, this is known as lambda operator. Okay, and then you might have just simple you might have a set of statements where the last statement is saying return and some kind of an int expression. Okay, this is one option. Okay. Another thing, because this, whenever any lambda expression is used, the context is always known what type of lambda expression it is representing, because I have said this is representing this is used in a context where an int binary operator is there. Therefore, I already know that the type of parameters will be int, and therefore, I can use a comma b. Okay. If there is a single statement, no, you can't just say return something, just put the expression without the return keyword. Okay. Fine. Lambda expressions, how to write them? If there is only one parameter and you are not specifying the type, you do not need to give the brackets. Fine. The parentheses are not mandatory. Fine. That is a different ways of writing a lambda expression. Okay. Fine. Let us proceed then. Okay. Next page. Okay. Now, another concept. Okay. Now, there are okay. Now, inside a lambda expression, now another point, yeah, this is also inside a lambda expression, what can I use? Okay, let us take some examples like this. I am writing some class A. So, we are writing some class called class A. Okay. Fine. Inside the class A, you might have some instance variables, int x, comma, int y. Okay. Fine. Now, I will just compare anonymous inner class, something about anonymous inner class I will just or a local, yeah, even anonymous inner class also have the same problems. Okay. Now, inside this I am having some method void m1 and it has its own local variable int a. Let me put some local variable a equals some value. Okay. A has been assigned a value, right? And then if I write a anonymous inner class, okay, suppose I am writing an anonymous inner class which is part of M1. Okay. Now, I just want you to recollect within the anonymous class. Okay, here let us say here is going to be an anonymous class. Within this anonymous class, can I use A? Okay, let me show. Okay, let me put the example of anonymous class here. Suppose someone says, or okay, someone is writing, if someone has to write a runnable object, right, he'll say runnable R1 equals, okay, runnable R1 equals. Now, as an anonymous class, if I have to write, I am just trying to make some comparisons here. New runnable, and then I will say public void run. And now the question here is, within this run method, can I use a here? Yeah, yes or no?
Yes, sir.
Can we use a?
Yeah.
Java 1.7. Can we use a? Java 1.7, let's say. Or okay, let me make another change. I have got int a equals 5. Okay. And then I have said a plus equal to 3. Suppose I have two statements like this. Okay. Int a equals to 5 and a plus equals 3, and now I am asking a question, can I use a inside the run method of the anonymous class? And it could be any version of Java now.
Yes, sir.
We cannot use a local variable of the enclosing method inside an anonymous class unless it is final. If a was final, I could have used it, but if a was final, the second statement here would not have been possible, right? Okay. So, a final variable, a final local variable cannot be used inside an anonymous class, and same thing applies to lambda expression. Okay, same thing is applicable also to the lambda expression. If I am writing instead of this anonymous inner class, if I was writing a lambda expression here, okay. So, if someone was saying let us have runnable, another way of writing runnable would have been using a lambda expression, sorry, runnable R2 equals, and then I write a lambda expression, no parameters taken by that method. So, am I able to use a here? If it is final, then yes. If it is not final, then no. Same rules as what is for anonymous inner class. It is similar. Okay. Now, the difference which comes, okay, suppose I do not have this statement, I have cancelled out the statement here. Okay. Then Java 8 onwards, a is still usable. A is usable. If you look at a carefully, okay, we have initialized the value of a and we have not changed the value of a any time. Okay. We are treating as if a is a final variable. Our code is just showing that a could as well have been final. If someone had declared a final, it would have been not making a difference, right? So, we have if we have local variables, or you have fine, if you have local variables which you may have not declared final, but have only a single initialization, then such variables are referred as effectively final. This variable is an effectively final variable and has now been allowed. Because it is effectively final, we are treating it like the way final is used. Okay. So, explicit final declaration for a local variable if not done, okay, but a variable, a local variable has been initialized only once and no other changes have been done in the code, it shows the code doesn't show that it has changed, it is no other assignment except for one assignment, okay, then such variables referred to as effectively final and are usable in the anonymous inner class as well as in your lambda expression. Fine. So, lambda expressions, what they can use and what they cannot use. Okay. So, they cannot use a non-final and non-effectively final. Okay. Fine. Effectively final is clear. What is effectively final? A local variable which is initialized only once is effectively final. You are just it's that you didn't declare final. Fine. So, it is effectively final, but your treatment of that variable was just like a final variable because it is not changing the value. Okay. So, effectively final variables are usable inside a lambda expression, okay, or inside even the anonymous inner class. Okay. Fine, clear on that? Any questions? Yeah.
Yes, understood.
Okay. Fine. So, lambda expression should be fine now, right? Creating a lambda expression is okay. Now, another kind of thing. Let's check this out. Okay, let's look at that. Okay. Now, let's look at some lambda expressions, and we have something called method reference. Let's understand writing a method reference. Okay. So, for this what I will do is, I am not now taking specific function types, but rather specific cases, some cases of lambda expressions and how they can be represented as method references. Okay. Fine, I will just try to explain how some of the lambda expressions, not all lambda expressions can be expressed as a method reference, okay, but some lambda expressions can be represented as a method reference. Okay. We normally put it like this: single method invocation. If there is a lambda expression which has only one method invocation, then we can also use a method reference. Okay. So, let us take a case, let us take a few cases. You might have a lambda expression which is like this. So, I am taking, let us say it has 3 parameters a, comma b, comma c, 3 inputs. Okay. And what it is doing is, okay, now this 3 inputs, it is only one statement, fine. So, you have a lambda expression which is only doing something like a dot some method m1 b comma c. Okay. Now, just for clarification sake, I am putting there is some data type for a in which m1 would be available, therefore, I am able to use m1 on a. Okay. So, a is of type. Okay. So, for our examples here, let us assume we have class A with method m1, class B has method m2 and class C has method m3. Okay. A, B, C are 3 data types, A, B and C. The variables here a, b and c are of type corresponding a, b and c. Okay. So, what it means is that the class A has a method m1 which takes as parameter b comma c. Yeah, 2 parameters, because I am invoking with 2 parameters. Yeah. Okay. So, there is I am writing a lambda expression which takes 3 inputs, okay, which takes 3 inputs and invokes a method. So, if I put that approach as the box approach, okay, there are a, b and c. Okay. But what is inside this box? The box simply says on the first input, which is a, okay, invoke the method called m1 which will use b and c. Okay. If this is what is the kind of lambda expression which you are writing, then it can as well be written as, what is the data type for A? A colon m1. It is nothing but invoking the method m1 which is available for the first parameter and consuming rest of the parameters. Here in this example, I have taken 3 parameters. Okay. The idea here is, whatever is the first parameter, on that a method is available, which is to which we are passing rest of the parameters in the same sequence, the remaining parameters in the same sequence. This is fine. So, a lambda expression which has, maybe I will write x, y, z for example, x comma y comma z, fine. What it is doing? On x invoking some method where parameters are going to be, the method's parameters will be y and z. So, that method, if I have to specify, I will say that method is on the type of x. Whatever is the type of x, whatever is the class or interface to which x belongs. Okay. Colon and the method where you are passing y and z as parameter, which is what I want to do here. Okay. Fine. So, one kind of lambda expression is, okay, it is here I have taken 3 parameters. Remember, instead of 3 parameters, suppose it was only a comma b, 2 parameters. Okay, it is the same thing. Suppose here I am assuming the method m2, maybe again I am putting m2 as a method of capital A. So, A has m2, let me not put here. Let us not worry about methods in this, but m1 has b and c, m2 has only b. Okay. M3 is there with no parameters. M3 is there with no parameters. So, if I write a comma b and doing and it says m2 with b as a parameter, okay, this would be written as a colon m2. Or if I have only a as a parameter and my expression says a dot m3, m3 does not need a parameter, this can be also written as a colon m3. Use m3 from A on the object which is coming as input. Fine. I want to use that method m3 on A, which is available from the type A, from the class or interface A. Okay. Fine. This is one way of writing lambda expression. One example. Fine. There are 3 cases, 3 different cases at least, which are very commonly used. One kind of case is this. First, so there are input parameters to a lambda expression, where the first input parameter is the one on which method is invoked, and rest of the parameters are used by that method in the same sequence, then you can just effectively specify it by mentioning the type name colon colon method name. You do not have to worry about any parameters or anything when writing this, because it knows what is the method signature, M2 whatever you are mentioning, it will be able to understand this. Okay. Now, another case of a lambda expression could have been where a static method is invoked. Fine. So, class A has a static method called, so let me put now the class also. So, you have got class A and this has a static method. Return type can be whatever is will not matter to us much here. Okay. I will again use 3 parameter, but you can generalize it. Return type is okay. Let me use the word here static method as the name of the method. Parameters are of type A, B, C. Now, this is a static method in, okay, it is in class A. This could have been some other type also instead of A. It could have been X comma B comma C, let us say. Fine. Suppose this is what you are doing. Sorry, this is a static method in your class A. So, class A has a static method which takes 3 parameters X, B and C. Types are X, B and C. Okay. We could have a lambda expression. Suppose there is a need of a lambda expression where you are writing a lambda expression which says 3 inputs according to the static method. So, it says okay, first parameter of type X. Okay. Let me reuse the same name. It could be any parameter name. Okay. B, C. What is being done in the lambda expression? What is being done? It says on A, it is a static method. I will use the class name and call the static method. I want to invoke the static method, and where I will pass the same thing in the same order X comma B comma C. If this is how you want to write your lambda expression, okay, find a lambda expression which is taking 3 inputs, and what it is doing, simply invoking a static method of a class. So, that class is A. So, on A colon colon whatever is that static method name, nothing else. No mention of parameters needed. All input parameters in the same sequence used by the static method of a class. Fine? Okay. So, you have class name or type name colon colon method, type name colon colon static method, okay. Or another form would be where, okay, let me take a, I will come to the example later, let us say. So, you have some got some object of whatever the type may be, it does not matter. So, maybe it is a string object, okay, string S, fine. string s is available, fine, it's a variable, and then someone says, let me put a lambda expression which takes 3 integers, sorry, which takes 3 parameters, or okay, 2 parameters maybe, yeah. Int start, int end, and here says s dot substring, yeah. Okay, fine. So let's take, we have string s, and someone says, I have a lambda expression which is taking 2 inputs, 2 integers as input, and on a string s, which is a variable, maybe it's a static variable or a final variable, effectively final variable, okay, equal to string, that could be a effectively final variable, some variable, some object which is available to me, right? Okay, and I am able to, the lambda expression is simply invoking a method on that object, passing the parameters which are the parameters to the lambda are straight away passed to the method s dot substring. Now, this can be written as, so this lambda expression could have been represented as s colon colon substring. See, the earlier 2 forms were giving type name colon colon method name. This one is object colon colon method. See, look at the all the 3 of them again. Okay. The first case is you have a method which is available on the first parameter of the lambda, and it can consume rest of the parameters available to the lambda. Okay. What you do is, whatever is the first type, first parameter type to the lambda, that type name colon colon the method, that is it. Okay. So, the expression is nothing but trying to, the lambda there would have been trying to invoke the method on the first parameter, reusing rest of the parameters. Okay. Fine. That is one case. Second case is with the static method. What you are doing in a lambda expression is simply invoking a static method, passing all the parameters which are come to the lambda expression, passing them all to that static method. Okay. Then you just give class name colon colon static method name. And the third one is where you have parameters coming to you in a lambda expression, and what you are doing is on some object you are invoking a method and passing those parameters to that method. All the parameters which have come to you in a lambda expression are straight away passed to the method invoked on the object. So, we will say that object colon colon method. Okay. So, method reference are written in these 3 cases. Okay. See, all these method references or all these lambda expressions, understand, they represent a function object. Fine. Let me come back to writing a lambda expression again. When I have written somewhere, initially I had written balance comparator, recollect that. I had written a balance comparator equals, and I have given a lambda expression here. What does the lambda expression say? It is a comparator which will take to account as parameter AC1 comma AC2, and I have some lambda expression here, okay, semicolon, right. This is assigned to a, sorry, I have not written that, this is actually a, this is a comparator of account. The data type for balance comparator is comparator of account. So, comparator of account, balance comparator equal to, and I have put a lambda expression. Fine. In the lambda expression, there is a whole lot of statements. Okay. Fine. I might have some next statement system out println. My question here is, when this statement is executed, right, where we have assigned a lambda expression to a balance comparator, okay, what has happened to all these statements? Have these statements been executed? When are these statements going to be executed? The statements in the lambda expression, when are they executed? I will put one more example. Multiplication 5 semicolon, this is semicolon, yeah. Then I say int binary operator again, op2 equals a comma b, and I have a square plus 2 into b, a square plus 2b, maybe something like this. Okay, fine. So, what is my question here? My question is this statement, this part, right? When is it going to be executed? Is it executed here? When this statement is executed, is this statement executed? Yes or no? Is this a plus b into 5 done when I have executed the statement int binary operator op1 equals, and I have given it a function? When is that function executed?
Using instance when we call the method.
Yeah. Fine. So, this statement, understand one thing, when the place where we are writing a lambda expression is not executing the lambda expression. Look at this as what? When I said int binary operator op1 equals this, here is a reference called op1, right? It is a reference type. Here is a reference called op1, and what does op1 have? op1 has a function. It has a function object. This is a function which has been created. It is like a function definition which has been created and made available to op1. It is not executing, it is creating. It is like defining a function and keeping it with op1. Okay. This is similarly op2 has another function. Okay. What we are doing is just creating objects which are of a type function. The type of the function is int binary operator. Okay. But then when will it be executed? Now, that int binary operator has an abstract method because of which it is a functional interface. Okay. And that method name is apply as int. So, sorry. So, for someone to actually when the method will be invoked, when someone says op1 equal, not equals, not assignment to OP1. It will have to be OP1 dot apply as int, and you should be giving two values a and b, 4, 5. When someone does this, that's the time when this is going to be executed. Okay. So, a lambda expression is not about executing the function, but about defining a function and keeping it as an object. So, it is just creating a function object. Okay. Where you write a lambda expression, it is not executing the expression. Fine. Many places this is referred to as lazy execution. Okay. Fine. Execution is not at the place where you see the lambda expression. It will be when someone will use that object and invoke a method. That abstract method has to be invoked.
Praveen, that apply as int, is it a
Method, it's a method. Apply as int is a method of int binary operator. Therefore, I am able to use on OP1.
What other methods are available?
As far as abstract method is concerned, this is the abstract method. There will be other methods also. Fine, there are other methods available, okay. But as far as this is concerned, okay, what is the function which is being defined? Oh, that is the function which is being defined. We are saying this is a function type, right? Int binary operator is a function type. So, if I say OP1, it is representing some function. What function is it representing? Oh, it is representing some function which given two inputs, right? Given two inputs will be returning an integer value. OP1 is doing it one way. Fine. I could have done OP1 equals to applies int and done some operation, and then on that same OP1 I could have replaced and given a different function altogether at a different point of time. That same variable now has a different function there. So,
Praveen, is it possible
yeah.
for you to execute this program in the editor and show it to us?
Okay.
Because that will make it clear for us.
Yeah. Okay. I think, let me switch to the editor then, right? Okay. Fine. So, let us say we want to use the int binary operator, right. So, we should have a class maybe. So, we have a public class okay, fine. Okay, let us keep a main method. I will need a few imports. I will need an import for java.util.function.int binary operator. Okay, let us use that int binary operator here. Okay, so this was a plus b into 5. Yeah. Fine, semicolon, right. or okay, just so that we can see when it is executed, when this function gets executed, let us keep a block where we will keep a system out println method. So, an entry into this, it will say system.out.println executing op1, executing a plus b. Let me say a plus okay. So, it will print that message executing a plus b into 5. Okay, and this is what it is returning, because now I have to have a explicit return statement here, and okay, semicolon. Where is this? I have to start a block here. So that block gets over here. That now here, yeah. Okay, fine, this is okay, and then I will just say system out println created op1, okay, and then I will say and that should be okay. Okay. So, creation of a object fine of type int binary operator. op1 is declared as int binary operator, and this whole lambda expression here, right, is nothing but a function which will be available from op1. Okay, let me save this test functional interface. Okay. Test function interface.java, that is what we have here, and let us go to the terminal. Okay. And got it compiled. Let us run this. Fine. So, first it has created, there is no it did not put anything which is inside the lambda expression, no output from there. Fine. It said, okay, I have created that object, that operator 1 has now been created, and then it is executing the operator. When we have called op1.apply as int. What is apply as int? It is the abstract method, a single abstract method of int binary operator. Okay. Okay. See, now if you want to use a method reference, okay, what could have been done? In this case, a better idea would have been to have a static method. So, public static method which returns int, okay, fine, because it has to return int, static method compute int a comma int b, and yeah, whatever is the code here, I just pick up from here, put it here. Okay. And this is from within compute. Okay. So now what I am going to do is the same thing. Okay. I have got int binary operator op2 equals test functional interface, sorry, colon yeah. See what is test function interface colon compute? It's a static method taking the parameters and returning the appropriate value of the same type, right? So yeah, we have done op2. Okay, so we can, just like we have done call on op1, we can do call on op2. Something like this. Okay. Test functional interface. What have we called this as test functional interface? T is missing here. Okay, let's compile. Yeah, and if we run, and so it has executed even from compute also. Okay. Okay, string dot length. Recollect, string has a length method. Okay, so let's say someone wants to write a lambda expression. First, create a object of type. What would be the type? Because it returns a int. Any function interface returning int. I know of some, but they are again from java.util.function. Okay. Anyway, I think that concept is clear, that there is some a way of writing function method references. What we will be doing is we will have more examples of method references coming as we go along. Okay. I have just shown one example of method reference here, fine, which is working, which was for the static method. Okay, fine. Another one, okay, again it will involve some other function interfaces which I will have to introduce first. Okay, so let us get introduced to the functional interfaces, some of the standard functional interfaces. Yeah, maybe we will be continuing next time, but let me just put it across. about the standard functional interfaces. See, what has been important for the one who is writing a lambda expression, he need not be knowing the he need not be knowing the name of the method. The one who is writing a lambda expression is not knowing the name of the method. Without even knowing that the method name is applies in, he is able to write a function. What is the knowledge he has? He knows what int binary operator is of a type where two integers are input and this is the output. He only knows that. Just with that knowledge, you can write a lambda expression. You can even write a method reference. For a lambda expression, you can always write a method reference if possible. Okay, it's not that all kinds of lambda expressions can have a method reference. Okay, and all kinds of lambda expressions cannot be having a method reference. Okay, so what we have is we have a package. This is a package called java.util.function. There is this package called java.util.function, and this is full of commonly found method signatures. So they have a standard set of functional interfaces, okay, for which lot of utilities and lot of things have been created. So everyone, everywhere, okay, most of the API, whatever API has been developed later on, they always talk in terms of if they have to use any functional interface, they will use this functional interface here. Okay, they will be using the functional interface which is over here from one of the functional interface from this package. Okay, because these are the standard set of functional interfaces. Sorry. Okay, so these are the standard set of functional interfaces available in this. And the idea here is the main categorization. I'll just give you the main categorization of these functional interfaces. So functional interfaces have been categorized as those kind of functions. Okay, functional interfaces represent those kind of functions which just take inputs, but return type is void. They don't return a value. We call them as consumer. Okay, one or more, whatever, fine, a different kind, but they take input as some, they take inputs, but they don't return a value, return type void, those kind of functions. Okay, another kind of category of functions would be they don't take any inputs, but they always return a value. This is a supplier category. They are returning, they return some value. Okay, another one which is known as, this is known as the type, the most common type here is, okay, we call it as a predicate. The category is predicate. They take inputs, but their return type is always going to be a boolean, true or false, testing. They always do some kind of a test. Predicate. So whatever input, maybe one input, two input, whatever, but they would just return a boolean value. We categorize them as predicate. Okay, and then much broader kind of a thing, we call this a very general thing, we call it as a function. A function means, yes, they take input and they return a value. Okay, if I put generic to this, I'll say, okay, a function from t to r. One input is t, return type is r. Or it may be someone saying, oh, it is a by function, so it takes two inputs, t and u, returns r, some such things. So there are various variants of this, but the broad categorization is like this. Within function also, you will have function which we call as operator. So you might have a unary operator, or you might have a binary operator. These are nothing but special cases of a function, unary operator and binary operator. When we talk of unary or a binary operator, the data types are same for input as well as output. Okay, they do some transformation and return a value, but input types and output types match. That's where we call them as operators. So it's a unary operator taking only one input, returning output of the same type, and binary operator taking two inputs and returning output, but all three types are same. Okay. So next time what we'll do is we'll try to understand these things, okay, and then come back again to using the method reference, and a place where these have been used, right? All these standard function interfaces and lot of things. I had given an example also. A place where many of such things have been used is a place called comparator. When we use this comparator for sort method, okay. So how comparators can very easily be created for most of your types. They can very easily be created, and any type of comparison logic can be given. So logic of comparison can be created very easily and very effectively. Even composite things, okay, first sorted by this and then ordering by this and then ordering by, so multiple keys ordering, even all such things can be very easily be done with comparator. So there are lot many static methods and even default methods which have been added to comparator. So we will review that so that you should be able to create comparators in a very easy manner. It's a very easy way to create comparator objects. Okay, I think, yeah, we can continue the next time. Fine.